Section 4.1 talked about the trig functions, sine and cosines and their graphs, and really how the stretching and scaling, stretching or squeezing, some books say it one way, some books say it the other way. For this one is translations. So before we had this a times the function. The function could be sine or cosine. And then we had a b times x. So we took care of this, and if you'll remember, since a was on the outside, it worked vertically. Since b was on the inside, it worked horizontally. If a worked the way it's supposed to, times 2 would double the height. It would stretch it vertically. Times 1/2 would take half the height. It would squeeze vertically or compress. b, inside the function, if you multiplied by 2, it wouldn't double it. It would take half. There would be 2 of those graphs, periods, in the same period there was before. And times 1/2 would be 1/2 period, so it would essentially stretch horizontally. Now we're going to look at translations, which I'm going to use C here for outside, and notice the extra parentheses, D on the inside. So let's assume that A is 1 and B is 1, so it really doesn't do anything. 1 times cosine, 1 times x. But let's assume that C and D are some values other than 0, because adding or subtracting 0 wouldn't change anything. So if we add on the outside, let's say we have 2 plus sine x. Or we add on the inside, y equals sine x plus 2. Let's look at fractions, I guess. It really doesn't matter in these cases because it won't move it any differently. The a's and the b's doubled and took half, but this one's just going to move it. Now, on the outside, if you add something, it moves it up. On the inside, if you add something, it moves it left. Once again, it's the opposite. Remember, times 2 did 1/2, times 1/2, doubled it. Same thing here. So let's look at a -2 plus sine x. Which way does that move it? Down. And let's look at sine x minus 2. Which way does that move it? You're right. Let's take a look at this using our calculator again. Turn it on. Let's go back to y equals. Clear out all this one at least, I guess. Now, we want 2 plus sine x. And we want, we should do sine x first. I'm sorry. Sine x first so we can have something to compare it to. And then 2 plus sine x. And we'll just do the sine x plus 2. So if we do this and just zoom trig, trig number 7. There's the normal. There's a period to the left and a period to the right of 0. Now we move it up 2, but it doesn't stretch it anyway. It just moves it up 2. Or we move it to the left 2. This was right here. It moved it 2 units to the left. Now because this is using the trig scales of pi, 2 pi, and stuff like that, let's, going from a -2 pi to positive 2 pi is fine. And we can put that in. I don't know why they don't do it exactly that way. We need 6.28. And 2 pi. That's what that zoom does. The scale, we're going to put this at the y scale, the x scale. We're going to now make these 1s so we can look at count forwards and backwards, and up and down. So now when we graph this, these don't match up nicely now with the pi over 2 and pi and 3 pi over 2, but they do match up with 1s and 2s. So this was where the point was. I'm sorry, this at 0 was where the point was for the original. And we can make that sort of stand out by making this a thicker graph. And we should have done that before. That's the original sine x. This is 2 plus sine x. This is sine x plus 2. So this is the original, go up 2, and this is now what it's moved to. If you draw a line at y equals 2, you'd have the x-axis moved up 2. Now you take this 0 and go back 2, and you get the start of your sine curve here. The vertical axis, so to speak, is now at a -2. Let's go back and change these to a negatives, though. So if I insert a negative here, that's a -2 plus sine x, and we'll do this with x minus 2. Now what should that do? Well, this -2 doesn't move it up, it moves it down, and this -2 moves it right. So when we graph these, the original sine x, move it down 2 for -2 plus sine x, move it to the right 2 for sine x minus 2. It's now starting here over 2. Okay. So what does that mean when we put them all together? We can use this to help us graph. And this is what I'm going to ask for also. Y equals c, AFB x minus d. Let's put that on its own page. I'm sorry, B is supposed to go there. Let me erase that for a second. Go back to my felt pen. This is B. And x minus d. Now we're going to put a minus in the form just to emphasize that when you subtract something, you're really moving to the right. So if d is a 2, you're really moving it right 2. If d is a -2, it'd be x plus 2, and what we're doing before. And we're going to have you fill out what is A, what is C, which of these 6 trig functions are you talking about, F, P, something not directly in the formula, but is the normal period for the trig functions. B is inside the function, stretch or squeeze, and D is inside the function. And you'll find these and be able to graph it. Okay, so let's put these all together. Just start counting, right? Y equals 1 plus 2 sine 3 x minus, let's make it a nice number, I guess, pi over 2. Okay. First of all, when I give you this, you're going to need to give me all the values. So, what is A? In this case, A is 2. What does it do? It's a vertical stretch. What is C? It is 1. Which way does it move it? Up. What is F? The trig function is the sine. And what I like to do is sort of draw a quick sketch. Normally, the sine looks something like that. What is the normal period, P, for the sine? 2 pi for sine and cosine. Both of them. What is B in this case? That's the 3. What does that do? Well, remember, outside it's the opposite. If you feel like this is a stretch, it's not. It's a compression. And D is pi over 2. I don't really care if you put positive or negative, but you should be able to say this is pi over 2 to the right. So, the last thing we'll do is we take P and divide it by B, and we get 2 pi over 3. This is the new period for our graph. So, what does our graph look like? Well, we know it moves up and to the right. So it's going to be more in the first quadrant. Okay. The order you work these is really a little bit strange. Do the moving up or down, that'll tell you where the middle is moved to. Then this stretch or squeeze, that'll tell you what the top and the bottom. So this is really the middle, and this is the top and the bottom, top and bottom. Then move down to D, do that third. This is where it starts. And once you figure out P over B, you can know where it stops, because that's how far you go after you start. So, number 1. Let me change this a little bit to a different color. Now, normally the center of the sine curve is at the x-axis. But now it's moved up 1. That's our new center. Normally, the sine curve goes up 1 and down 1 for the top and the bottom. But in this case, it goes up 2 and down 2. That's our new top and bottom. Normally, the sine curve starts here at the y-axis at 0, 0, but the y-axis is where it starts. Now, it's going to start pi over 2 units to the right. This is the new starting point. And normally, it ends 2 pi units later, but now it's going to end 2 pi over 3 units later. So what is that point? It is pi over 2 plus 2 pi over 3. Now if you just write that, that's okay with me. If you want to, you can add those together and figure out where that would be. But now you have this window. You break that in half, and in half again for each of these. And remember how you graph the sine. It starts here, goes up, back to the middle, back down, and ends here. And this is now the sine curve. Now, how do you check that? You use your calculator. Let's see here. Just turn this on and go to y equals and get rid of everything else. In y1, we're going to put the original 1 plus 2 sine 3 parenthesis, x minus pi over 2, close, close. That's the original. The window, we're going to use the window we made here. What's the x min? Well, that's pi over 2, this line right here. Pi divided by 2. What is x max? That's over here at pi over 2 plus 2 pi over 3. So we go pi divided by 2 plus 2 pi divided by 3. Scale, well, I don't know what these are exactly here. It'd be nice to put marks here, but see, there's 2's and 3's, so maybe pi over 6. I don't know. It doesn't really matter to figure this out. What is the y minimum? Well, this is -1. I didn't write that in there. Should write that in there. Up to 3. So, let me put this back up. -1 is the lowest value, up to 3. And here I can use 1 as a scale, the tick marks. Once you got that set up, the function, the window, you should be able to graph this, and it will put it right in the middle. And this window, these will always all look the same. It'll look just like that, but it's supposed to, because that's what you made this window do. You might say to yourself, okay, what does this look like, I guess, with all the rest of the parts? Let's zoom out for a second. And that's what it really looks like. What we're choosing is this part, pi over 2 units, to this part, pi over 2 plus 2 pi over 3. We're just looking at that little window right in here. But it's moved up and to the right, so that should also help you. One last thing about these trig functions, at least sine and cosine. The distance from the center, to the topmost point, that is called the amplitude. It is really this value 2. That is the amplitude, from the center to the top, or the center to the bottom. The amplitude. What is this movement to the right? That is the phase shift. Now that's when you have subtraction, at least. That is this number you subtract from x, the phase shift. So if they're asking about the amplitude, it's the A. If they're asking about the phase shift, it's the D. Let's do another one, this time a cosine. Y equals 4 minus 3 cosine x minus pi. What is A? A is a -3. You have to include that negative. So this is a stretch and a flip vertically. C is 4. That still moves it up. The function is cosine. It looks sort of like the cereal bowl. Period for the cosine, just like the sine, 2 pi normally. B is 1. So P over B will still be 2 pi. And D is pi, since we're subtracting it is to the right. So this is still up and to the right, and it's going up pretty high. So let's put it someplace right here. Change our colors. First step. Where does the middle move? Normally the middle for the cosine is right here, the x-axis, but it is moved up 4. This is now the middle. Step 2. Normally it just goes up 1 and down 1, but this stretch means it goes up 3 and down 3. Skip down to D. Step 3. Normally the cosine starts at the y-axis, but now it starts pi units to the right. And you might say, how do I know that's pi? Well, we're going to assume that you know that that can be stretched or squeezed here. We won't worry about being exactly right. It's not drawn exactly to scale. And we know that 2 pi units later from pi would be 3 pi. Halfway between is 2 pi. That's nice to have there, since you take this, divide it into fourths. Then, remember, don't forget this flip. It starts down here and then goes up, back down, and your graph is the cereal bowl that your little sister or brother has spilled because they turned it over. But that's the graph. Are you sure? Let's see, this was step 4. Well, let us bring up our calculator and find out. First of all, y equals, clear this out, 4 minus 3 cosine x minus pi, parenthesis, window. Well, it'd be nice to mark some of this stuff. This is pi and 3 pi over 2. That's good. But this is now 1 and 7 that can help us. So a negative is positive pi here for this. And it goes up to 3 pi. I guess we can use pi over 2 as a scale. Minimum is 1 for the y. Maximum is 7. Scale can be 1 there. And now when you graph it, you should see the cereal bowl upside down in the window. If you want to see what it looks like zoomed out, you click zoom number 2 and then press enter. What did I zoom? Oh, zoom number 3 and press enter. It takes you back to where you were. We'll leave this is where the center of the zoom is, and press enter again and it'll zoom in. Okay, that's what I was looking for. That's what's happened to this. It's really not down on the x-axis what this looks like. It's off it just a little bit, 1 unit. And that's how you should be able to do these in section 4.2. So one last example from Trig section 4.2, problem number 66, page 163. This is a calculator problem. It is a list of the data for the fractional part of the moon that is illuminated. They want us to plot the data, use a sine regression to determine a model, and then graph the equation. Also, I'd like us to look at how find the values, I guess, for A, B, C, D by using the graph. And show you that it's going to be very close to that sine regression. Now, to make this a little faster, I have, and you'll need to do this because it takes a little time. Once you get your calculator turned on, here at the bottom of page 163, you press Stat and Edit. And in L1, you can choose any one you'd like, but I guess L1, you're going to put 1 through 30. Just count as you go. That's one's pretty easy to put in. And then for L2, you're going to put in the data that they have for their fraction. So the 0.73, the 0.63, etc., etc. There's 30 of those data points. So you're going to have to make sure you do it. Take your time. You don't have to race through that. If you make a mistake, it'll throw things off. Now, how do you plot the data on your calculator? You can do this with some graph paper too, and it can be pretty nice, really. If you go above this y equals, second y equals, you get to the stat plots. Unless you need more than one, I always choose number one. And first thing you do is turn it on. The type will be a scatter plot. This first one right here. These others you'll get to learn about with statistics. The X list is L1. You can do, if it's not L1, make it second one, and you get to the L1. The Y list is L2. That would be second 2 to get to the L2. The mark, I'm going to use these big boxes, but you can use a plus sign or even a little bitty dot. And it depends upon how you want it to look. That sets up your stat plot. So you've entered your data. You've set up your stat plot. Now you need to figure out what the window should be. There is a quick way of doing that on your TI-84. You do a zoom and go down to number 9, zoom stat, which doesn't mean do it really fast. Zoom stat. Press enter, and it will do all this. Now, what I'm getting of this other stuff, and I'm glad I did that, is a bunch of junk. Because in y equals, I have this equation still from the last example. Let's clear that out and press graph. You can do a zoom stat again, but the window has been set up. So you can press just graph, and that's the data. Pretty nice looking sine curve, tell you what. Now, if we want this to find a regression curve, I'm going to do that in a second. But I want to show you that you can do this pretty easily without that. This goes down to 0, we know that. And the highest value is this one over here. If we trace this, it will jump to all those data points. 0 is the lowest one. And then when you get up here, the highest one is 1. There's 0.99, there's 1. So, remember, the amplitude, or A, is halfway, I guess, between the bottom and the top. So we know that A, if we go from 0 to 1, must be 1/2, because that's half of 0 to 1. The C, has this been moved up? Well, yes, the center is no longer at the origin. The center is up. Well, it moved up, I guess, to 1/2 also. because it's been moved up to 1/2, and this is stretched up 1/2, stretched down 1/2. It's really a compression. So let me write that down. So 1/2 for C. The function is the sine. The period for sine is usually 2 pi. What is B? Well, let's see. The x values go from 1 to 30. Right? So this is really 30 units that this thing is for its period where it starts and ends. But you got to be a little careful, because I think we might be in a little trouble if we go back to the graph, because we can't say it's 0 here, because 1/2, if we look at these data points again, so let's see, if we get, there's 0.49 for y. This really has to start over here at this data point right here, if you follow me. It's like it's cutting a previous part that should have been tacked on over here. But this is the center, and so that really starts someplace, one of these two, whichever we'd like it to be, I guess. So that's how far it's been moved to the right or the left. Let's see, that's 4 or 3, right? I don't know what to make it. We'll make it 4. What the heck? So the we know that the D is 4 to the right. P over B, if we know that 30 is the new P over B, then we can figure out what B is, because we know what P is. 2 pi over B is that 30. So 2 pi over 30 is the B, or that's pi over 15 is the B. So we have an equation. See if I can squeeze it in here in a different color so it'll stand out. We have y equals C, which is 1/2. It's moved up 1/2, plus 1/2 because it's been compressed vertically 1/2. The sine of the B, which is pi over 15, x minus, because it's been moved to the right, 4. We'll see how that works. That is our equation. I'm going to put that into y2. So go y equals, and in y2, you're going to do 1/2 or 0.5 plus 0.5. Sine pi divided by 15, parenthesis, x minus 4, close, close. Let's see how that fits. Let's see how well we've done with that. Let's graph this. Oh, man. What did we do wrong? Well, remember the sine curve goes up and then down and then up. This is going down and then up and then down. So we could, I guess, start it over here, but notice how good we did here. Anyway, but we can just say, you know what? What I want is this thing to be flipped over vertically. So instead of y 1/2 plus 1/2, I'm going to have 1/2 minus 1/2, and now graph it. See how well that fits? We did a pretty good job just by looking at the graph. Now, there is built into your calculator a regression feature. Regression means it's going to take this data and fit an equation to it. If you press Stat, right arrow to Calc, go down to these first: median, median, linear regression, quadratic regression, cubic regression, quartic, that's degree 4. Another linear regression, the statistics, people's a plus bx instead of ax plus b. Natural log regression, exponential regression, power regression, which is really a power for the x to some power. Logistic, which is what the coronavirus is doing for us, and the sine regression. So if I press enter, now for each of these regressions, you've got to tell it which two lists. If you've got the new operating system, it'll say X list and Y list. If you don't, you'll have to put those down. The X list was L1, and then a comma. That's the key above the 7. But you just put it for the new operating system, put an L1 by the X list. Second 2 for L2. For the Y list, you need another comma if you've got it like mine. And then you can store that. So there's a store regeq that you can fill in. And we're going to put that in Y1. How do you get a Y1? You can't type in alpha, Y, and then a 1. You got to go to these variables right here. Vars and then the Y variables. Function and Y1. So now when you press enter, it's calculating with that little worm moving. And it's still moving. I don't know how long this takes. It shouldn't be that long. There it is. Now, notice what they're giving us. They say a times sine bx plus c. Now, we got to be careful. This b and the c are connected here. If you factor that out, you've got to divide c by b. So it's a little different than ours because we've factored out the b. But let's see here. What do we get for this? Well, the 0.496, that's the a. And the 0.21, that's the b. I wonder what pi over 15 is. And the 2.3, that's the c. Well, that would be pi over 15 times 4. And the d is 0.47. Well, I'm sorry, that's what the d is. C is pi over 15. No, c is 1/2. What the heck? Oh, because they're starting in a different spot with this data. Let's see what the graph looks like. That's the y1. I guess they did a pretty good job. And here is our y2, which is almost as good, off a little bit maybe. But these numbers should be the same. I'd like to find out what those are. Let me write this down again. Second quit. So there are two things going on here, really. We called this 1/2 C. They called that D, and that was 0.478, which is pretty close to 1/2. We called this A, so did they. They called it A. Ours was a negative 0.496. We'll take a look at that in a second. The B is 0.21002, and if you take pi divided by 15, you get 0.209 instead of 0.20, where's that at? 0.2100. So 209, 210, about the same for B. Now we've got to take their C is really our D that's been multiplied by pi over 15. So that number, pi over 15 times our D, which is 4. Press enter, and you get 0.83 pi over 15 times 4. Oh, that's because it, and that's the other difference there. They didn't use a negative because they didn't move it to the right, the same place we moved it to. They didn't flip it over. They just moved it. So instead of moving it 4 units to the right, they only moved it not even 1 unit to the right. So when we graphed this thing was starting way over here, so that it could end up here. Does that make sense? Because they added instead of subtracted the C, They really went back 2 units to start it over on this side. Anyway, the point is, we did okay with just our little formulas and graphs here. Now you should be able to do everything, and those are pretty cool little problems in that section at the end.